they discovered the sequence of the primes? For real?
Basically, the thing is we don't understand the sequence of primes all that well.
But they really did discover the sequence of the primes.
Prime numbers have spin. How so?
For example, the prime number 5, in yellow in the circle, stands on top of 25, a square, in blue. The prime 5 spins toward another composite, 85 in blue. We call this prime spin. It works very well in clock math.
The old way is the sieve of Eratosthenes. The new way is modular arithmetic, aka clock math, where we find prime spin. So we're going to do clock math, and we're going to put it on our poster. Primes are only located at 4 different times: 1 o'clock, 5 o'clock, 7 o'clock, and 11 o'clock. As a fun fact, there must be an even number separating each prime, and an even number separating each composite. Let's take a look at more sophisticated clock math. So the clock did not disappear. We put it on our poster board, all the different hours here, as the numbers get bigger and bigger. Mathematicians call this modulo 12. So the primes are in yellow, and the primes are at 4 times: 1 o'clock, vector 1, 5 o'clock, vector 5, 7 o'clock, vector 7, and 11 o'clock, vector 11. Notice that the numbers are getting larger and larger as the clock expands, and so are the primes.
If you want to be very technical, 2 and 3 are primes, but you'll notice that they're very strange kind of primes. At 2 o'clock, you won't find any other primes. 3 o'clock, you won't find any other primes. That's because there's no choice. Between 2 and 1, there are no factors other than 2 and 1. Between 3 and 1, there are no other factors other than 3 and 1. So the numbers are so small, there's no room for any other factors. That's where a lot of mathematicians make a huge mistake. They focus on 2 and 3 being primes, and they don't realize that if you go to clock math, you can get rid of 2 and 3, and you could focus on the real prime numbers, the prime numbers 1, 5, 7, and 11, which generate the pattern of the primes. If you eliminate the composites, you will be left with, in yellow, the primes.
Looking for large primes? No worries. You'll find large primes down Clock Math Road. So now we're looking at 1 o'clock, which is vector 1, that's 1 o'clock. We add 12 to get to 13, add 12 to get to 25, and we keep adding 12. Just as a reminder, primes are located only in vectors 1, 5, 7, and 11. That's 1 o'clock, 5 o'clock, 7 o'clock, and 11 o'clock. This is how we quickly locate primes between 1 and 100, and this is using clock math, and we're only at 1 o'clock, and we're only looking at all the numbers that fall at 1 o'clock, vector 1.